Alright, ladies and gentlemen, welcome back. We're going to go 6.2 now with the law of cosines. Alright, we're going to be solving triangles with the law of cosines. Now, don't freak out, there's no such thing as law of tangent. So, this law of cosines and the law of sines we've already done, those are the only two laws we have to deal with. Alright, now the law of cosines is, as it says here, the Pythagorean theorem modified for non-right triangles. Okay, well, hopefully, c squared equals a squared plus b squared isn't too much of a shock for us. Then notice we've got this minus 2ab cosine c term put on there. And again, we have similar ones in these other two formulas, but basically that's it. It's just, hey, I have a right triangle here. Well, no, I don't, so I need this other term to kind of make everything work. And it does make mathematical sense. If you want me to show you why, I'll be happy to in class, but here we go. So here's the formula. It's just written 3 different times based on which angle basically you're talking about at the time. The way I remember these formulas is that every letter shows up twice. Okay, if I'm talking about c squared, that's where the c is the angle that I'm using. If I have the b squared on the left by itself, b, etc. And then I've got the kind of right side of the Pythagorean theorem, if you will, the a squared b squared, and then notice the a and b show up here, the formula. A squared c squared, ac, b squared c squared, bc. Alright, now this formula is useful when you have side angle side or side side side. Okay, again, looking at the letters here, those are mostly sides we have, so when we have our arrangement of various parts of the triangle and it's mostly sides, this is a good formula for that. And remember, the law of sines was best when we had lots of angles, basically. So at least that's one way I make my decisions. If I see lots of angles, I think law of sines. If I see lots of sides, I start thinking law of cosines. Alright, the book gives these other forms. You can take a look at those if it works for you. I don't like to bother with any more than what we have right here because I just don't like to memorize stuff. And that's just memorizing another form of the equation. But if you want to, feel free. Alrighty, well, let's take a look at how one of these guys plays out if we're dealing with kind of a law of cosine setup. Alright, so I've given these 3 parts of my triangle, angle B, side A, and side C. So again, my first step is going to be drawing a not-so-great triangle, A, B, and C. Okay, C is 73 degrees, so I'll put that up there. Little a is 15 units, whatever it is. C is 24 units, and there we go. Okay, so notice we have our side angle side set up. Okay, now one little side note on this is keep in mind side angle side is a congruency theorem, so there's no chance whatsoever of me having more than one case, so that kind of helps. Alright, so I don't have to worry about that sort of thing, so hey, let's start doing the formula. Okay, now I have angle B, and if I'm going to deal with the law of cosines, basically I need all 3 letters, or all 3 sides. So I've got A, I've got C, and so I need basically a little b over here. Okay, so the version of the formula I'm going to work with is the one that starts with the b squared. So I've got b squared equals, okay, and then I've got a squared plus c squared. And really, because you're adding them, the order doesn't matter. So put them in what order you like. I'll just go with 15 squared plus 24 squared. It's alphabetical, but again, it really doesn't matter. And then minus, and again, the AC shows up again. So basically, whatever numbers you have being squared here, just use those exact same numbers again. Okay, and then you've got the cosine of whatever angle is across from the side you're trying to find. So there's our 73. Okay, now the good news is, everything on the right side of this equation is a number. So basically, you can type that thing in your calculator all at once. And if you do that, you get b squared equals 590, that's a 9, 0.492, and a bunch of other decimals. Okay, of course, at this point, we need a square root of both sides. So we do that, and we finally get that little b is 24.3, and then there's a few zeros there. But overall, as far as like a final answer area over here, I've got 24.3. Okay, now I'm going to label this over here just because I want to make a point later. Because notice that 24.3 and that 24 are not too far apart as far as measurement. So basically this angle is not too far away from being isosceles. Or triangle, I think I might have said angle, but you get the idea. Alright, but anyway, so there's B. And once I've got that, okay, well, I'm pretty much stuck trying to find an angle measure. And, well, I think law of sines is kind of good for that sort of thing. So I'm going to find an angle here, and I'm going to go sine of, well, what do you think? Okay, one thing, I'm purposely always going to find the smallest angle possible with the law of sines, because remember, law of sines has that little issue where if it's supposed to be an obtuse angle, it doesn't actually give you the proper measurement. So I'm going to look at my sides of my triangle and think, okay, who's the smallest angle? And, well, since I have my smallest side here, the angle opposite that A is always going to be my smallest side. So I'm going to go sine of A over 15 as half of my equation. And then the other half, well, I don't really have much of a choice. I'm going to have to use sine of 73 over the 24-point icky decimal that we had here. So sine 73 over 24.300. Again, you have to use those other decimals because if not, your answer is going to be a little bit off. Okay. After doing a little bit of cross multiplying and all that kind of fun stuff, inverse sine, I eventually come up with A equals 36.179. Again, lots of icky decimals going on forever, which then, as far as the final answer, gives me a 36.2 degree angle. And from there, all I need to know is big C. So again, this is 36.1, or let's just put the 2 in there. Okay, and again, big C, okay, again, he's across from a 24, and this B was across from a 24.3, so if this is a 73, I'm guessing my C should be a little bit lower than 73 because the angle, or the side, is a little bit lower than 24.3. Alright, so anyway, before I babble on forever, 180 minus the other two angles that I have is a nice solid 73 minus the relatively yucky 36.179 that we just found. But again, that should be the last number on my calculator screen right now, so it's not too hard to come up with that. And doing a little subtraction, I get 70.820 and a bunch of other icky stuff. But again, notice the 70 is pretty close to that 73 that we had earlier, so I feel pretty good about it. Think about it, I got a 40 right there or something, I'd have to say, whoa, wait a minute, something's wrong, and check my work. Alright, but anyway, there you go. That's how the law of cosines plays out. But notice we really just used it once, and then just broke into the law of sine stuff from there. Alright, now let's take a look at what happens if you start out with all three side lengths. Basically your side, side, side. So here we go again. First thing first, draw yourself a reasonable, well, or even unreasonable triangle. Get little a is going to be 14, little b is going to be 19, and little c is going to be 25. Okay, now here's the thing about using inverse sine versus inverse cosine. Okay, using the law of cosines now. Okay, eventually if I'm going to find an angle, I'm going to have to do an inverse cosine. Well, the good news about inverse cosine is if I have an obtuse angle, inverse cosine actually gives an obtuse angle back. Remember, law of sines, the inverse sine never returns an obtuse angle back. So basically, as a just kind of plan of attack here, if you will, okay, anytime I'm going to use the law of cosines to find an angle measure, I'm going to find my biggest side, and then use the angle across from it and find that angle. Because if there's an obtuse angle in this triangle, it's going to be C. Now again, just from the numbers, without doing some calculations, I don't know for sure whether or not I've got an obtuse angle at C, but if there is one, he's going to be the winner. So basically I'm going to use the formula with the 25 squared on the left, because that's the formula that's going to have the cosine C on the right. Alright, so 25 squared, 14 squared plus 19 squared, remember those two are irrelevant as far as the order goes, minus 2 times 14 times 19, and then your cosine of C. Now keep in mind that this is basically a variable right there. In fact, it's exactly a variable to C. But basically what it means is I have 3 terms on the right-hand side, only 2 of which are like terms. So since this guy's got a variable, I have to be careful about how I handle things. Okay, that being said, 25 squared is 625. Okay, and then just for time's sake, I'm going to put the 14 squared and 19 squared together right now, and that works out to be 557. One of these days I'll learn not to use too many 5s in a problem. Alright, and then the 2 times 14 times 19, here we go again, is 5, here we go, 32, and I've got cosine C. Okay, and again, the mistake that's commonly made here is people try to subtract these two, but again, there's a cosine attached to this guy and not to the 557, so you can't. So what we can do, though, is subtract the 557 from both sides, and that gives us something around 68 equals our negative 532 cosine C. Alright, from there we subtract our 532. Sorry, did I say subtract? Divide the 532 from both sides. And that gives us cosine C equals whatever it gives us, negative 0.1278, icky decimals forever. And then inverse cosine, and remember, if it is obtuse, I get an obtuse measure, so a 97, hey, it is obtuse, 343. Okay, a little preview right here is, now that I found that this is 97.3 degrees, okay, at least the rounded version of it is that, okay, I can now eventually find either A or B, and then the way to find the third one that we haven't found yet is to do 180 minus the 2 that we have. And again, if I want this guy for a future calculation, I better save it right now. So again, it might be a good idea to store this guy in the memory someplace in your calculator. So just keep that in mind as we go through this. Alright, well, that being said, at this point, now I'm missing angles A and B. And again, using the law of cosines to find an angle measure is a very good way of doing it, but notice it's quite a few steps. So quite honestly, given the choice, I'm going to use law of sines because it's just generally quicker. So what I can do is I can do my sine of the 97.343, again, use all those nice decimal places, over the 25, so I basically have my c fraction. And then again, if I'm going to use law signs, I'm going to find my smallest one just out of practice. So I'm basically finding sine of a over the 14. Alright, and after a little bit of cross multiplication and whatnot, I eventually get a equals 33.738, again, icky-decimal. So there's a 33.7 after a little bit of rounding. And then, like I said a little bit ago, that to get big B, all I got to do is take 180 minus the 2 we already found, so minus the 33.738 icky-decimal, also then minus the 97.343, and that eventually gives us big B is 48.917, and after putting that in the proper rounded form, I get 48.9 degrees. Okay, just for those of you paying attention, if you add those up, it isn't exactly 180, and I'll leave it to you to figure out why that isn't exactly 180, it's actually 179.9. But I'll let you figure that one on your own and leave you anticipation. Alright, so anyway, Heron's area formula. Okay, just like with the law of sines, there's an area formula associated with it. Law of cosines has the same thing. Okay, now looking at this formula, it looks like a big mess, and believe it or not, it's actually derived using law of cosines. Just in the derivation, all the trig stuff actually kind of disappears, and you're just left with this big square root and this kind of fraction-y sort of thing over here. Okay, but here's the formula. For any triangle sides A, B, and C, the area equals this big old thing where notice you got the S showing up, and then it's S, which stands for semi-perimeter, which might help you remember how to do it. Semi-perimeter. Okay, and it makes a whole lot of sense if you just think about this for a second. Well, if I take A plus B plus C, which are the three sides, and add them up, well, that's the perimeter. And dividing by 2 is half, and the prefix semi means half. So you're doing half the perimeter. So big shocker right there if you kind of analyze the word. Alright, but anyway, so the area equals big old square root semi-perimeter times semi-perimeter minus each of the three sides separately. You multiply the whole thing together, square root the whole thing, and whatever comes out, comes out. Alright, so basically, what you got to do here, though, is figure out S first. Okay, you'll see the formula usually written with this thing first and then the S thing second, but you have to actually do them in the other order. Okay, now I'm going to use a script S because sometimes my S's look like 5s if I'm not paying attention. Okay, so first thing first, I've got to take my 11 plus 16 plus 24 and divide it all by 2, and that gives me the value of S of 25.5. I'm using 5s again. Okay, so again, that's just a nice number that I'm going to have to use in this formula repeatedly. So now, from there, area, separate this thing, equals big old square root. Again, the messier the number, the messier this thing's going to look. But 25.5, parentheses, and then again, depending on how good you are, you may or may not have to write all of this out, but here it is anyway. We got 25.5 minus the first side, 11. Okay, but also, since I'm multiplying these three things together, or 4 technically, the order you do them in doesn't really matter. So 25.5 minus the 16, and then the 25.5 minus 24. Okay, now admittedly, depending on your skill at mental math, typing that in the calculator is really kind of awkward. So I'll admit what I do before I type in the calculator is I just do these little calculations right here. And 25.5 minus 11 is actually going to be a 14.5. Okay, 25.5 minus 16 is going to give me a 9.5. And then 25.5 minus 24 is a 1.5. And that's just a little bit easier to type in the calculator. Alright, but anyway, typing all that in gives me the square root of 5,268.9375. Actually comes out nice and clean that way. And then hitting the square root button on that gives me an area of 72.587 ... But then again, basic rule of round to the nearest tenths here gives me an answer of 72.6 square units. So basically that's that formula and how I use it for area. So all you need to know is all three sides, and again, whether or not you have a right triangle, you can use this formula and figure out the area if you needed to. Alright, there's it. Any questions, ask me in class. See you then.